Okay, try that again. The closed points, the included points are always at the left end. The open points, the holes, the non-included points are always at the right end. Okay. Did everyone figure out how to graph down their calculator now? Okay. Domain. Thoughts on domain. What x values are included? All of them? Because there's always something, isn't there? From here, 0 to 1, all those x values are included. Here, 1's not included, but it's included up here. Same, so on and so forth. So this does go on continually. So my domain is negative infinity to positive infinity. It is all reals. What about range?
I don't know how to put it, but it's just like the 1 to like non-decimal numbers.
Does that make sense? What are you going to say, Jacob? Okay, yeah. And, I agree. It's one of those, how do you put it? But, so from here, my y value is 0, right? These stair steps don't connect, do they? So here my y value is 1. Here my y value is 2. The next one would be 3, 4. Are the decimals included? Like Craig's point, the decimals aren't included, right? It's those whole numbers. The only thing is, we also have to include the negative whole numbers, negative 1, negative 2. And so I just have it written as all integers. I don't know, there's a fancy little letter for all integers, but at this point we usually just put all integers. Okay? Okay, questions on those? Okay, flip the page. Now, as I say flip the page, you want to leave it so you can get back to that previous page, right? Because we're going to be kind of going back and forth. And I don't know, I'd prefer to give you guys, some work time. So I don't know that we're going to answer all of these questions, but I at least want to talk about some of them. I actually think I'm going to skip question 1, honestly, just because I don't think there's anything exactly like that in homework. So let's go ahead and talk about example 2. So you have graphs on the previous page, right, that you can flip back and look at. You also have your calculator, you can use it as an aid. Only 3 of the 12 basic functions are even. Which are they? So, oh, wait. I just read the wrong problem, didn't I? Dang it. Okay. Supposed to be looking at example 2. I just read example 3. I'm having a moment. Okay. Let's back up to example 2. I do like example 2. We'll talk about it. But only 3 of the 12 basic functions are bounded, both above and below. Which 3? So I am looking for 3 answers. There are exactly 3 correct answers. There's not more. There's not less. Okay, so flip back and look and kind of look at those graphs. Remember bounded, bounded above, bounded below. Okay? Give me one, Jacob. Okay, and actually I'm going to flip back here and look here. He says the logistic function. Is that bounded above and below? Yeah, because it's almost, there's like asymptotes running at 0 and 1. So I agree, the logistic function is 1. Okay? Whitney, what's another one? Square root function. It is not bounded above, which is below. I could go there, but, and part of it is probably my graph might look a little misleading, but yeah, as you go to the right, this does infinitely go up. It doesn't have a spot that it tops out at. Otherwise, I could go with that. And the hint there is because my range goes to infinity. that would be the reason I wouldn't go for that. Okay? Natalie, you got one? She says the cosine function. What do you guys think about the cosine function? Is there a spot it never goes above and never goes below? Never goes above 1, never goes below -1, right? So cosine function. Craig, you got another one? The sine function. And kind of once you get one of them, we kind of know they go together. But same idea, isn't it? So those are the three that are bounded above and below. Okay? So I'm going to flip back over here to example 2. And I'm trying to remember what I did in the answer key. We said sine, cosine, and logistic. Which, that's what they are by name. If we give them by equations, it's y equals sine x, sin x. It's y equals cosine x, cos x. And y equals 1 over 1 plus e to the negative x. Okay? So those are the answers I'm going to write there. Again, I need to grab the answer key and look. I want to say for what you're going to see tomorrow, did I do the equations on the answer key? I don't remember. I did do the equations. That doesn't make the names wrong, but what you're going to see is the equations there. Questions on that? We okay there? Okay, now let's try example 3. 3, so again, I'm looking for 3 specific answers. Of the 12 basic functions are even. Which are they? Let me ask you a question. What does it mean to be even? Okay, the easiest thing to rely on is the fact that it is symmetric across the y-axis. Okay. Yes, it also has that whole f of x equals f of negative x thing. But if we're looking at the graphs, isn't it easier to just look for symmetric across the y-axis? So can you spot 3? Give me one, Jacob. Cosine. So here's the deal, guys. If it's symmetric across the y, we can take that graph and fold it at the y-axis, right? Is that true? Both sides are equal, aren't they? So yes, cosine is even. It is symmetric across the y-axis. Okay? So yeah, I agree. Probably one of the tougher ones to figure out there. Natalie? Absolute value function. Well, again, can I fold that v at the y-axis? Definitely can. So absolute value function. Ethan?
I don't even know what you call it, a squaring function.
Are you just going to call it the parabola?
Yeah.
I would have known what you meant. Okay, the squaring function. Parabola, folded this one's centered, right? Fold at the y-axis. Okay, did we get them? Okay, so when I'm going to list those 3, we said the squaring, which is y equals x squared. We said the absolute value, which is y equals absolute value of x. And we said cosine, which is y equals cos x. Okay. Some of your, I don't know how many of you guys looked at any of the homework last night or if you just waited for me to finish talking about the graphs. But some of the homework questions are like that, right? Name, blank amount of graphs that do this. Now, you also have some questions, like example 4. The last handful of questions on homework are like this. So, let's look at example 4 here. graph the function f of x equals x minus 2 quantity squared. So grab the calculator to do just that. Parentheses x minus 2 parentheses quantity squared. I say I always do. I'm going to do a zoom 6 because I was last zoomed in. What do you see going on here? It's a parabola. What's been done to this parabola? Shifted 2 to the right, because your algebra 2 rules tell you that, right? The graph tells us that, but our algebra 2, if it's in the parentheses, opposite direction of the sign. So, that's what we're going to be talking about, is that parabola that shifted 2 to the right. Now, I'm going to take a moment, and I'm going to sketch this parabola over here, so I can draw on it and point at it. Basically, I have a parabola. It looks something like that, right? Nothing fancy. Okay. A. On what interval is the function increasing and then decreasing? So back in lesson 1.2, we learned some stuff like this, didn't we? We learned what it meant to be increasing and decreasing. So when is this function increasing versus decreasing? Do you remember? Connor? So first thing we're going to do is if you start on the left side of this graph and we move from left to right, this graph is going down, isn't it? Okay, so that graph is going down as we move across the graph from left to right. So that is my decreasing section. When did those x values start decreasing? Well, whenever the graph started, which is negative infinity. When are they going to stop decreasing? At this minimum point here. And this minimum point, the x value is 2. Parentheses or bracket on that 2. It's a point, right? We touch that point, so it is a bracket. Now, what happens after you hit that minimum at 2? We now hit our minimum low point, so now we're going to go up. As I go up, as I move to the right, I am increasing. When did I start increasing? When I left that minimum point at x equals 2. When do I stop increasing? Never, so infinity. So we're going to say 2 to infinity. 2 has a bracket. Infinity always has a parenthesis. Okay, so that's one of the things you'll have to do in homework. You'll have like a 4-part problem like this. Okay, is the function even, odd, or neither? Okay, why is it not even? Okay, if it was even, it would be symmetric across the y-axis. This is not symmetric across the y-axis, is it? It would be if it was centered, but it's been moved. So it's not even. Is it odd? Do you remember what it means to be odd? That's back in lesson 1.2 as well, isn't it? Symmetric across the origin. Which if it's symmetric across the origin, it kind of ends up reflected or rotated to a diagonal quadrant. Well, what do you know about this graph? It's pretty much It's just all in this quadrant for the most part, isn't it? I mean, I guess as you go up, it crosses, but is there anything down here that looks like that to be symmetric through the origin? No. So that means that this one is neither. I like this next problem because it's a very easy problem, but if you don't remember the vocabulary, it's very tricky. Does the function have any extrema? Do you remember what it means to be an extrema? What am I asking for? Any mins or maxes, right? So when you see on a quiz, a worksheet, a test, are there any extrema? I'm asking, are there any mins or maxes? That's what I'm asking. So does this function have any extrema? Yeah. What's it have? A minimum at x equals 2, or at the ordered pair 2, 0. So I'm going to say there's a min. I'm just going to say at 2, 0. Yes. If it asks, you can. I mean, it is an absolute minimum because that is the lowest the graph would ever go. Yep. It's a local minimum also because every minimum's a local minimum. But yes, I agree. This one specifically is a absolute minimum. Okay. And D, how does the graph relate to the graph of the basic function y equals x squared? Well, if you're paying attention, we already answered this. Yeah, it's translated 2 units to the right, isn't it? We talked about already that it's a parabola, and it went 2 right. That's a big old algebra 2 concept. So, I'm just going to put here that it translates right 2 units. So yes, there's 4 parts to that one, but I think they're good parts. It connects us back to lesson 1.2 and gets us thinking in those ways. You guys want to talk about asymptotes real quick? Let's talk about asymptotes real quick. So A, 2 of the basic functions, so notice it says 2 of them, have vertical asymptotes at x equals 0. Which 2? So vertical asymptote at x equals 0, that's a vertical asymptote on the what axis? Y-axis? What are you thinking, Natalie? Okay. Natural logarithm function. Does that have a vertical asymptote there? Yeah, we talked about this graph is never going to cross over 0 there. So natural log is one of them. We need 2, right? So there should be one more. Jacob? The reciprocal function. If you go right above it, the reciprocal function, it has the graph on either side, but it never touches the y-axis, does it? Okay? And that's, again, just looking at the graph and being able to tell that. So for A, let's see, what did we say? We said the reciprocal function, which is y equals 1 over x, and we said the shortcut and say natural log, which is y equals ln x. Any log graph is going to look similar to that. So, okay. B, to finish this off. 3 of the basic functions have a horizontal asymptote at y equals 0. So I'm looking for horizontal here. Where are their horizontal asymptotes? Basically on the x-axis. Okay. Give me one, Jacob. Logistic function. Talked about that one at the end of class yesterday, didn't we? Logistic function never goes below the x-axis. And it's not that, there's lots of graphs that never go below the x-axis, but it runs alongside the x-axis. So logistic is one of them. Ethan? Exponential function is another one because, again, it's running alongside the x-axis, never crossing, never touching. And Connor? Not the square root function. Not the absolute value function. And I'm going to say no to those for the same reason. They have a point at the x-axis, but they don't run alongside the x-axis. So that's the difference. We need something that runs alongside the x-axis as it goes off either way. What? Nope. Squaring is going to be no for the same reason, like the square root and the absolute value, because it just has a point there. Tori? The reciprocal function. And the reciprocal function probably looks a little different to you guys because there's things on either side of it, but we're never going to cross or touch the x-axis. Over here, you run along the top of it. Over here, you run along the bottom of it. Okay, so in all honesty, I forgot what three we had. Logistic, exponential, reciprocal. Logistic, exponential, reciprocal. So logistic is that y equals 1 over 1 plus e to the negative x. Exponential is y equals e to the x. And reciprocal is y equals 1 over x. Okay, are we getting it? Got the idea here? Okay, I want to give you guys some work time. So I'm going to, we've got the basics out of the way. Your homework, which I just realized I haven't written down here, is on page 106. Yes, it seems like a lot, but like the first 12 is a matching series, if I recall. 1 through 24, 29, 30, 34, 35, 38, 39, 41. So yes, a little bit longer than normal homework, but again, the first 12 are a matching series. The second 12 are you're going back and looking at that matching series, which I can, if you get those books out, the first 12, there's 1 through 12, and you're matching with A through L up above. Okay, so it's those graphs, but they're moved a little bit. So you're just matching with the equation. Okay, yes, you could eventually graph them on your calculator, but I would try and match them based on the pictures in your notes first, and then use the calculator as a check. When you get down to 13 through 24, no, actually, I take that back. It's 13 through 18. It's asking us to use numbers 1 through 12 to talk about which of those graphs do which thing. So 13 through 18, your answers are, number 10. Number 10 has this happening, or, whatever the case is. 19 through 24, more like what we did in class, and then some of the others, like what we did of the set of 4, the ABCD. Okay? Due tomorrow. Let me know if you have questions.